Good evening everyone. Today's topic signal and systems. Topic basic operation on signals. A definition of signals. A signal is a physical quantity that varies with a time, space or any other independent variable, or a signal carries some kind of information from one end to another. For example, AC signal, image, TV signal, speech signal and audio video signal. There is the operation on signal, time shifting, time folding or reversal, time scaling, aptitude scaling, signal multiplication, signal addition and subtraction. First one is the time shifting. The process of shifting the time based off the signal is called the time shifting. For example, the shifting of a signal is x of t is performed by replacing the independent variables t by t minus capital T. So get the time shifting signal t minus t, where t represent the time shifting in second. For example, y of t is equals to x bracket t minus capital T. In these signals is shifting in time. It means that a signal may be either advanced in time axis or delayed in the time axis. If x t minus t, if capital T is positive, then the time shift result is delay by t seconds. If x t minus capital T, if t is negative, then the shift result in advance of the signals by t seconds. Consider a time shifting signal x of t minus t. Signal x of t as shown in below, x bracket t minus 3 and x t plus 4. So we shift the left side by 4 and x of t is delayed by 3 and x of t advanced by 4. So this is the time shifting example and their definition. Second one is time reversal. The process of folding, reflection or transpose of continuous time signal. The folding of continuous time signal x of t is performed by a changing the sign of time base t in the signal x of t. A time reversal of signal x of t can be obtained by folding the signal about t is equals to 0. It is denoted by x bracket minus t. The folding operation produced a signal x of minus t, which is mirror image of the original signal x of t with respect to origin t is equals to 0. Consider a signal x of t as shown in figure below. Now to draw the second figure, the signal is folded with another region and the signal x minus of t plus 1 is obtained by delaying the x of minus t by the 1 unit of time, and x of minus t minus 2 is obtained by advancing x of minus t by 2 units of time. And this is the reverse and delayed signal, and this is the reverse and advanced signal. This is the time reversal signal. Third one is time scaling. Expansion and compression of a signal in time is called a time scaling. If operation either compress or expand the signal duration depending on the scaling factor. If the scaling factor is greater than 1, the signal is compressed in time, while if it's between 0 and 1, the signal is expanded, stretched in time. So definition is a time scaling involves multiplying the independent variable time of a signal by constant factor. For continuous time signal x of t and scaled signal in represented x of at, where a is scaling factor. And this is the example of time signal. If greater than 1, if the scaling factor is greater than 1, the signal is compressed, and if while if it's between 0 and 1 is signal expanded the signal. So the time signal applications is speech processing, adjusting the speed of speech recording, and signal compression, reducing the storage space of a signal by compressing its time duration. And also properties of the time signal. Time scaling affects the frequency spectrum of signal. For a continuous time signal, scaling by a result in a frequency spectrum that is the scaled by 1. And the second is fourth one, amplitude scaling. The amplitude scaling is performed by multiplying the amplitude of the signal by a constant. For consider a signal x of t is fed to an amplifier with a gain 3. The output of signal of an amplitude can be represented by y of t is equals to 3x of t. Output y of t is identical in a shape to the input signal x of t, but its amplitude is a twice everywhere. So the signal is given signal is a amplitude scaling. And fifth one is the signal addition and subtraction. The addition and subtraction of the two continuous time signal is performed by adding or subtracting the value of the two signal corresponding in the same instant of a time. The sum of a two signal x1 of t and x2 of t is a signal y of t whose value at any instant is equal in the sum of the value of these two signals at that instant. For example, y of t is equals to x1 of t plus x2 of t. This is the formula of addition, and the signals of this is the given diagram of addition, and also vice versa the using subtraction signal. This diagram below this diagram shows the subtraction signal. And in direct time signals, the sum of two signals can be obtained by adding corresponding values. And sixth one is the signal multiplication. The multiplication of two CT signals is performed by multiplying the value of performed two signals corresponding to the same instant of time. The product of two signals x1 of t and x2 of t is a signal y of t whose value of any instant is equal to the product of the value of these two signals, and that instant y1 of t is equals to x1 of t into x2 of t. The input is x1 of t and x2 of t. These two are input, and this arrow shows the output of y1 of t is equals to x1 of t into x2 of t. And these are 6 basic signals operations: addition, multiplication by a constant, time shifting, time scaling, and time reversal. These operations are fundamental in manipulating and analyzing signals in various applications like signal processing, image processing, and speech processing. In short, we studied addition. Adding two signals involves summing their corresponding values each time instant. Second, multiplication by a constant. This operation scales the amplitude of a signals by a constant factor. And third one is time shifting. This shifts the signals along the time axis, either delaying or advancing it. Time scaling. This operation compresses or expanded the signal in time. Time reversal. This flips the signals across a vertical axis, effectively reversing its direction. These basic signals, along with their variation and combinations, are essential for understanding how system responds to different inputs and for performing signals analysis techniques like Fourier analysis, Laplace transform, and Z transform.